So where have we got to? We've used two simple equations to look at the forward pass and the backward pass of a logic network. That network is a sequence of activities in building some facility, some asset, computer system, building a system, maintaining an asset that you've shut down, a chemical process or a pharmaceutical process, used in lots of different areas. That's what you could do to get the period, which is the shortest time we could do this project in. What we notice is that the late starts and the early starts are different in some activities, and in other activities, they're the same. What does that mean? Well, if we think about it, it means that, for example, C, activity C, its early start is 5, its early finish is 12, but its late start is 25 and its late finish is 32. That means it can move in time in a lateness from 5 to 25 before it affects the end date of the project. So that has a certain quality which this activity B doesn't have, because the early finish for B at 15 and the early start of 5 for B are exactly the same as the late start and the late finish. That means if in any way this starts later than that early start, that will affect the end date of the project. So this activity has got a more important quality, and you're beginning to get the idea of where this word critical comes from, because these are critical activities. So the property we're alluding to is a property that has been known over the years as slack, and it's now more often known as float. It's the amount of time contingency that exists on any activity, the amount of movement in time that activity can have before it affects the end date. And there are a number of different degrees of float, but we're going to stick with the simplest one at this stage in the game, and we can see all that in a more extended session somewhere else. So this equation that we need to think about for the total float, people conceive of doing that with a simple subtraction of the early start from the late start, or the early finish from the late start, the late finish rather, and that gives you the answer most of the time. But many of the people who've written on this subject of critical path analysis, let me think, probably Albert Lester, Keith Lockyer, and another Albert Battersby, who wrote a lot on operations research as well, always indicated that what you should do is cater for every eventuality. And the equation that does that for looking at what is known as the total float looks like this. You take the total float, we'll call it TF, and that equals the late finish minus the early start minus the duration, and there's our equation 3. And that works all the time. That works all the time for all the different types of conditions that you can get. So armed with that one, we can start anywhere on here and work out what our floats are. So very simply, the total float on activity A is the late finish of 5 minus the early start of 0 minus the duration of 5, and that gives us simply 0. So our float there is 0, and I forgot to mention that that's what goes in this cell down here, the total float, that little cell at the bottom. If we go and look at B, we can repeat that, and I won't go through the tedium of doing the thing again, but I'll just say it's 15 minus 5 minus 10 is 0. Where it gets interesting, of course, is on activity C, where you can see that the application of that equation shows us the late finish minus the early start minus 7. That's 5 and 7, so it's minus 12 in total. It's going to give us 20. So the total float there is 20. If we look at activity D, it's 15 minus 5 minus 8. It's going to give us 2 there. Looking at activity E, you've got 27 minus 15 minus 12, which is 0. And for activity F, it's 39 minus 12 minus 7, which is going to give us 20. Activity H is 39 minus 27 minus 12, 0. And G is 39 minus 19 minus 11, which is going to give us 9. Now the last activity that we've got to float on that one is going to be 48 minus 39 minus 9, which is 0. What do we conclude from this? Well, those activities with 0 float are known as critical activities. And those critical activities means that if there's any delay in any of those activities, then the whole project will be delayed. And the path of those critical activities is known as the critical path. Hence the name of the technique, the critical path analysis. Now, when you use this technique with software, it automatically colors everything, but when I was a boy, we had to do this with essentially red. And I'm going to draw in the critical path in red. So there we have it. There's the first part of the critical path. There's our second part of the critical path. And the next one on the critical path is here, down from E down to H, and then H up to J. And we would also probably cover those activities there like that and say these are our critical activities. We'd mark them in red, and some of the software will do this automatically, which is much nicer than this. Although, over the world, I find most people like to have this explained in this way. So there you see it. It might beg the question, what are those other two boxes for in my little cell down at the bottom there? Well, people like to put in here perhaps the activity number, AN, and sometimes they like to put the activity resources in there. Resources could be manpower, it could be money, it could be materials, or it could be all three. And that would take us on into using this technique for developing resource schedules using a bar chart. And I believe that you have to have a network to do a sensible bar chart. If you don't have a network underneath the bar chart, which will be the subject of another video, if you don't have that, then what you have is a cosmetic technique. So if I can summarize, what I've done with you is to do a forward pass in a network. I've also done a backward pass in a network, and I've then analyzed the network for criticality, or the critical path. So those three things make up the key features of critical path analysis. A terrific technique in project management, and one that you all want to understand, even if you do it on software, just to be able to discuss this with your colleagues and understand why your colleagues are planning. And in project control, talk to you about the importance of the plan. It's really important for the health of the project and the team working in the project. So that's essentially critical path analysis.